My name is Evelyn Ramirez. I'm in General Physics 1. My group is Group 5, and my teammates are Angie Macario, Abigail Musier, Clarissa Ceros, and this is our video presentation for Lab 1. So today we will learn and practice using a motion sensor to replicate and create position time graphs. More specifically, we will be creating one-dimensional time graphs. So for this project, each team member chose a given graph to replicate using slow to fast movements to replicate the positions of the given graphs. So you're probably wondering, what are position time graphs? So position time graphs plot the position of an object at a certain time. It would demonstrate its velocity at certain points of the graph, and as well as the resting points of the object. The time will be in the x-axis of the graph, and the position will be in the y-axis.
Materials. For this lab, the materials we used consisted of the motion sensor, an iPad case, and the computer program called Capstone. The motion sensor we are using is called a passport motion sensor. It emits ultrasonic pulses that bounce off an object, recording how long sound waves take to hit an object and come back. With this data, the sensor has the ability to calculate an object's velocity, position, and acceleration. The Capstone program works with the passport sensor to plot out the data on the graphs. For this lab, we worked with the position versus time graph. The units we were using were meters and seconds. The iPad case was used in order to have a set object the motion sensor could focus on. This prevented other objects from being accidentally recorded and possibly disrupting our results.
In the next section, we will replicate the chart for LRTA using the ultrasonic motion detector. By using this tool, we can generate speed charts that visually demonstrate how an object velocity changes. Replicating these charts not only helps us understanding the principles of motion, but also allows us to compare our data directly with the TA's reference results. This process ensures that we gain a clear understanding of how to read and interpret speed charts in practice. First, these processes were more challenging than we expected. One difficulty that we faced was interpreting what the charts were actually showing. The lines on the graph represent position, velocity, or acceleration, but distinguish between them and understanding their meaning took extra time. Another challenge was getting our replicating charts to match the TA's examples. Small errors in setting up the detector or in how we recorded the data led to results that looked different from the ones we were aiming for. This forced us to repeat some trials and pay closer attention to the setup. Although it was difficult at the start, working through this problem helped us better understanding how ultrasonic detectors collect data and how to interpret the speed charts they generate. The process of struggling, rechecking, and adjusting ultimately gave us a clear picture of motion graphs and how velocity is calculated in real time, as we saw in the last section. In conclusion, even though we faced challenges interpreting and replicating the charts with the ultrasonic motion detector, the experience strengthened our understanding of motion analysis. The difficulties we encounter push us to pay closer attention to both the setup and the meaning behind the graphs. By the end, we not only learn how to correctly replicate the TA charts, but also develop greater confidence in interpreting speed, velocity, and acceleration data. This process shows us that mistakes and obstacles are an important part of learning, and they ultimately deepen our grasp of how motion detectors functions in real experiments. In this case, the usage of this tool to make charts similar to the ones presented in the lecture.